Vodcast 6C is all about Lewis structures. I'm going to walk you through step by step one example. I'll do two more, and then you'll have to do two on your own. What is a Lewis structure? A Lewis structure is a picture of a molecule. It tells us how the valence electrons are going to be arranged. Each valence electron is represented by one dot. The dots are shown in pairs. A stable compound has all of its atoms in a noble gas-like configuration. So everybody wants to get to 8, that's that octet rule, except for hydrogen, which only needs 2. There's also an exception for boron or beryllium, but we won't ever get into the exception. So a bonding pair would be this right here. It's a pair of electrons that forms a bond between two elements. A lone pair does not form a bond. It's only attached to one atom. So if I have hydrogen and chlorine, chlorine has lots of lone pair or unbonded electrons. They're only shown around chlorine, not around the hydrogen. So the pair represented here by a line, you can also represent it as the two dots, same thing, would be the bonded pair of electrons, and then the dots on this diagram would be the lone pair or the unbonded electron. So the first example I'm going to do for you is the nitrate ion. Within the nitrate ion there are covalently bonded atoms, the nitrogen and the oxygen. So it's NO3 with a 1- charge. First step, you have to figure out your total number of valence electrons. How do we do this? You've got to look back on the periodic table. Here I wrote a list of all the elements that I have. Nitrogen is in column 15. It therefore has 5 valence electrons. Since there are 3 oxygens, I had to list them twice. Each oxygen coming from row 16 gives me 6 valence electrons. Plus, I have 1 extra electron because I have a 1- charge. If I have a 2- charge, this would be a 2. If I had a 1 positive charge, I'd have to subtract 1, not add 1. So I'm adding all these up. 5 plus 6 plus 6 plus 6 plus 1. I get a total of 24 electrons. That's how many electrons I have. Step 1. Step 2. Figuring out the total number of electrons that you need. Every element, except for hydrogen, will need 8. So since I have 4 atoms here, 4 times 8, I need 32 electrons. Multiply the number of your atoms by 8. 4 times 8 gives me 32. Unless you have hydrogen, then you would only get 2. So your numbers here are either going to be 8 or 2. Step 3. Figure out which atom goes in the center. Now I'll give you a couple big hints. First, each molecule wants to look symmetrical. So if you have a single atom, it will usually fit in the center. You can also look at who is the least electronegative. Remembering electronegativity increases up and to the right, so you're looking for something, whoever's further left or further down. The central atom is usually written first. Nitrogen's written first. It's also least electronegative. You can look on your chart and look at the specific numbers too if you don't want to worry about the trends. And it cannot be hydrogen, and it cannot be a halogen. Nitrogen is not hydrogen, and nitrogen is not a halogen. Therefore, nitrogen goes in the center. Step 4. Calculate how many bonds you have. You're going to need those numbers that you used in steps 1 and 2. How many bonds did you need? We needed 32. how many, sorry, not bonds, electrons. We needed 32 total electrons. We only had 24. And since one bond equals 2 electrons, you have to divide that by 2. 32 minus 24 is 8. 8 divided by 2, I get a total of 4 bonds. Now, step 5 is to draw the picture. You have to put nitrogen in the center. You need to bond it with 3 oxygens, but you have 4 total bonds. How does that work? Draw out nitrogen. It would be bonded to 3 oxygens, but that only used 3 bonds. Here it said I needed 4. So you can put the double bond anywhere you want, since they're all nitrogen-oxygen bonds. So this picture right here is exactly the same as this one. The double bond can go on the left, it can go in the center, and it could go on the right. That's how you know if you have a double or triple bond. Now, since each electron, or each pair, is 2 electrons, in this diagram here I use 2, 4, 6, 8 of my total electrons. 8 of them are bonding electrons, but how many did I have? I had 24. Now I've got to fill up the rest. Make sure each element has their full 8. So nitrogen has 2, 4, 6, 8. He's happy. This oxygen over here only has 2. So that's when I add the dots in pairs, 3, 4, 5, 6, 7, 8, so that each element has a total of 8 valence electrons. This guy would look the same because he only has 2 over here on the right, 3, 4, 5, 6, 7, 8. This oxygen looks a little different because it already has 2 plus 2 or 4 valence electrons, so I only need to add 4 more. Add them as pairs, 2, 4, 6, 8. So that's how you add the remaining electrons to fill the octet. Now each element in that picture has 8 electrons surrounding it. Step 6. Make sure step 6 and 7 really are just double checking yourself. Do you have all the atoms that you should? We did NO3. Do I have 1 nitrogen and 3 oxygens? You look at your picture. I do. Since this is an ion, you have to put this in brackets and just show that I have a 1- charge. And then here are some extra hints. Only these elements are able to double bond. C, carbon, O, oxygen, N, nitrogen, S, sulfur, and P, phosphorus are the only ones that can double bond. So here my double bond is between nitrogen and oxygen. I'm okay. Only 3 elements, carbon, oxygen, and nitrogen, are able to have triple bonds. So if you needed to draw a triple bond, it must be between 2 of these 3 elements. Here are some exceptions. Again, this is just to show you that there are exceptions. We won't ever go into any exceptions. Boron can be stable with, for some reason, only 6. Sulfur can exceed its octet and have 2, 4, 6, 8, 10, 12, and that's stable with 12. Iodine here has 2, 4, 6, 7, 8, 9, 10 can also be stable. You need to look for the 8 for the octet. Now here's this thing with a double bond again. This is called resonance. When you can draw the same structure, here the double bond is on the right, here it's on the top, and here it's on the bottom. There can be 3 valid structures for this molecule. It doesn't switch between, the double bond doesn't change, you can just draw it 3 different ways. And if you would rotate this molecule to the left, you'd get this one. Rotating this one again to the left, you'd get this one. So it's really just 3 different ways to look at the same thing. So there will be 3 valid structures called resonance for this, a drawing of a Lewis structure for this molecule. Alright, how do I draw a Lewis structure for the following compounds? I'm going to list my steps. You may want to keep these handy. How many electrons do I need? How many do I have? How many bonds does that give me? Who goes in the center? I draw my structure, and then I use those hints to double check. So I'll do the first one, and then you can do water. SO2. How many electrons do I need? Everybody needs 8, except for hydrogen. I don't have hydrogen. Sulfur would need 8, oxygen would need 8, oxygen would need 8. 8 times 3 is 24. But how many do I really have? Looking at your periodic table, sulfur is in column 16. It would therefore only be bringing in 6 valence electrons. Oxygen, being in the same column, would also only give me 6. How many do I have total? 6 and 6 is 12. 12 and 6 is 18. That's step 1 and 2. Step 3. How many bonds does that give me? How did I figure that out? Need minus have divided by 2. 24 minus 18. 6 divided by 2. I get 3 bonds. 3 bonds total. Now, who goes in the center? Center atom is usually written first. Central atom is the least electronegative. Again, look at your chart or just use the trend. Since sulfur is below oxygen, remember we're looking for something either lower or to the left, sulfur has to be my center atom. It also wants to look symmetrical. So I put sulfur in the center, and I put oxygens around it. You can go top, bottom, you can go left, right, whatever makes it look symmetrical to you. Now, I have 3 bonds, but I only have 2 spots. So where can I put it? Again, this compound would have resonance. You can draw your double bond on the left, or you can draw your double bond on the right. I have 1 sulfur, 2 oxygens with 3 bonds. Now, is everybody happy with their full 8? Looking at sulfur. Sulfur has 2, 4, 6. I need to add 2 more electrons to sulfur. This is where I add the dots to fill it in. Oxygen over here only has 2, so it'll need 3, 4, 5, 6, 7, 8 to make a full octet. The oxygen on the right has 2 plus 2 or 4, so it only needs 4 more for 5, 6, 7, and 8. Try this water. Remember when you're looking in your need column, that hydrogen only needs 2. The oxygen will need 8. We'll go over this one when you come to class. I'm going to do NH3, last example. Same things. How many do I need? How many electrons do I have? How many bonds does that give me? Who goes in the center? How do I draw it? And then double check yourself. Listing out all of the elements that we have. We have N, H, 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 NH3. You can draw your columns. This chart just helps me to keep organized. How many do I need? Everybody needs 8, except for hydrogen, who only needs 2. 8 plus 2 is 10, and 2 is 12, and 2 is 14. But how many do I have? Nitrogen is in column 15. That means it has 5 valence electrons. Hydrogen, column 1, only has 1. 5, 6, 7, 8 total. 14 minus 8 divided by 2 tells me how many bonds I get. 14 divided by 8 is 6. 6 divided by 2, I get 3 bonds in this case. Who goes in the center? Well, I said before that it cannot be hydrogen, so it has to be nitrogen. Why can it not be hydrogen? Hydrogen only needs 1 more electron. Hydrogen can only form 1 more bond. Nitrogen has to go in the middle. Nitrogen gets 3 bonds. It's nice when it works out that it's bonded to 3 things as well. Hydrogen's happy with 2. That one's done. Hydrogen's happy with 2. That one's done. Hydrogen's happy with 2. That one's done. How many more electrons do I have to add? 2, 4, 6, 7, 8. That's my drawing. Double check yourself. How many electrons did I have? This will always equal how many you drew. 2, 4, 6, 7, 8. I have 1 nitrogen, 3 hydrogens, 3 bonds with my 8 electrons. Draw CCl4 the same way, using the same steps, and we'll go over that one as well in class.